Assalamu alaikum everyone, and today we are going to talk about the hyperbola. So, after learning about the parabola, we in the end talked about another mysterious shape, another mysterious conic section. Now what is that mysterious conic section that I talked about? That's right, the hyperbola. It was in my intro, if you paid attention. So, yeah. Basically, the hyperbola is a plane like this, unlike a parabola, which goes straight to this corner, and at a glance, the hyperbola kind of looks like a double parabola, side to side, like a parabola like this, and then another parabola like this, a double parabola. Well, I mean, it is close to a double parabola. I mean, it's very alike to a parabola. It has kind of the same shape like that, but it is more related to an ellipse than a parabola. Let me tell you how. So, like I was saying, a hyperbola is more similar or can be compared to an ellipse than a parabola. Well, it is as if the both have two foci. But the difference between the fact that these have foci, that is, in the ellipse video, we learned that the sum of the distance of one point to one of the foci plus the one point to the other foci is constant, or R1 plus R2 is constant. But in a hyperbola, it's not exactly like that. Let's say the hyperbola is a little more opposite. Let's say one distance to one foci to a point in the double parabolic thing, and the other foci, both of their differences are taken into account, which means we can say it like R1 minus R2 is constant, because we're talking about difference here. Oh, and by the way, it can be on either side. So the difference will remain constant. So basically, this will have a very close equation to an ellipse. An ellipse's equation would have x squared over a squared plus y squared over b squared equals to 1. This hyperbola has the same equation, but has differences. Let me erase everything and write that down for more understanding. This is the equation for an ellipse, and this is the equation of an ellipse, the top one, and the bottom one is the hyperbola. And there's not much difference. In fact, the only difference is instead of a plus, there will be a minus, because it's not the sum, but the difference. Remember that when you talk about something like a sum, you mean addition. When you talk about difference, you mean subtraction. That makes sense because 3 and 2 have a difference on 1. that's an example. So 3 minus 2 is 1, and the sum is addition. That's it. So that's what we have to apply here. And there are a few, let's say, variation differences here. Like in the ellipse equation, a squared and b squared was able to switch sides, and x squared and y squared couldn't. But here, x squared and y squared can, and a squared and b squared can't. So basically now the variables are that a is the distance from the center to a vertex. Oh yeah, right, I totally forgot. It's not only the focus that counts, or the foci. Foci is the plural of focus point. So these are the vertex, like the points, and between them is the center, and these are all are on the transverse axis. And we'll talk more about the variation on transverse axis later on in the video. And C is the distance from the center point to a focus, like this much, let's say. So basically the equation would be c squared equals to a squared plus b squared. I know this looks exactly like the Pythagorean theorem, but it's not the Pythagorean theorem. That's why I didn't write it in the regular, as you say, a squared plus b squared equals to c squared. It's very confusing. You just have to look at the question. That is it about triangles in geometry or trigonometry, or is it about graphing conic sections about a hyperbola or an ellipse, let's say. So yeah, that might get a lot confusing, okay? Let's take an actual equation of graphing a hyperbola. So something like x squared over 16 minus y squared over 9 equals to 1. Here, a squared in our c squared equals to a squared plus b squared equation. That's what I like to call it because I get confused with the Pythagorean theorem again. So a squared is 16 and b squared is 9. So a is equal to 4 and b is equal to 3. I know I said it in a really slow way because it isn't much of a difference. It's just a calculation. But here comes the equation. In this equation, when we plug the value of the squares and the actual numbers, we get 25. And this is c squared. To take the square root to get the actual c, what you have to do is just take the square root of 25 to get 5. And with all these, the way that when we understood about C and A, we have enough information to make a sketch about our equation into a hyperbola. So this will be a graph of this equation. Now remember how I said that the x's and the y's can switch? Let's do that. If these are switched, the transverse axis is the y-axis now, not the x-axis. It's the y-axis. So this is basically an example. Now, unlike our ellipse video where we talked about every single example, about every single situation, here we don't, because all we need to know is that we can also go from coordinate to equation, like with vertices of -2, 0 and 2, 0, and something like a foci, which is -5, 0 and 5, 0. And with all this, we can understand that A equals to 4, B equals to 21, and C equals to 25. And so the equation for this is x squared over 4 minus y squared over 21 equals to 1. And again, like with the ellipse, if anything is getting divided, if it's not 1, we just divide by the same number on both sides, and that's it. And we can also vary the center point here, like in this type of equation. And clearly that's all here. Now we've finished talking about graphing conic sections. Now the next algebra video would obviously be about graphing, but it'll come later. So the next video would probably be something about science. So that's all there is to it. So let's review. Let's review what we have learned from this 4-part series. We've learned about graphing conic sections, and conic sections are type of shapes that come from a cone, which is why the conic sections like that. So these are the circle, the ellipse, the parabola, and the hyperbola. And the circle is very easy, and an ellipse is very important for astronomy, and it introduces 2 foci. And a parabola is something like y equals to x squared and everything like that. And we learned that the hyperbola is more like an ellipse than a parabola, and it looks like a double parabola. And we've learned about its things, like unlike an ellipse, which has like something like 2 foci, the distance from a point to the one foci and adding up the distance from that same point to the other foci is constant. But here, the difference is constant. And with all that, we've wrapped up about conic sections. So by wrapping this up, that's all there is to it. You can subscribe to my channel for more videos. You can like, comment, and share, I guess. And thank you for watching, and I will see you next time. Bye!